All right. Folks, this is our warm-up here. It's called sum and product. Sum meaning like S-U-M meaning like add, and product meaning multiply. So our goal here was to find a pair of integers, right? So that means like not including decimals, but like positive and negative, I suppose, whole numbers. That add to this number here, and the same two numbers will multiply together to get the number in this column. So, for example, we have here 5 and 4. When they add together, it equals 9. And then the same two numbers multiplied by one another gives you 20. So that integer pair is the only integer pair that'll do that. There's no other integer pair that'll do both of those things. So it's almost like we're kind of cracking this like code. So Ryder did B for us. How about C? Yeah, what do you got? Yeah, and does the order matter in which I write them? No. So we'll say -2 and +8. Yeah, 8 plus -2 is, yeah. And when you get to the bottom here, you got to think, and sometimes the trick is like, I always start with what we're multiplying to, because if we're multiplying to a negative number, that means that our integer pair, one has to be positive and one has to be negative. Has to be. That's the only way you can multiply to a negative number. But when you multiply to a positive number, they could either both be positive or both be negative. So you got to kind of be careful with that. So how about this one here? These are the ones that bother me here, because it's like the last thing that I think of. Multiplies to 5 and adds to 6. What do we got here? Yeah, 1 and 5. Yeah, those ones always slip my mind. +1 and +5 for sure. How about the next one here? E, -4 and -21. What do you got? 3 and -7. Yeah, -7 and 3, or 3 and -7. Now, some people might get these signs mixed up, right? They may have put -3 and +7, which wouldn't work. I mean, it would still multiply to -21, but it wouldn't add to -4. It would have added to +4. So the signs here are pretty important. How about the next one here? Adds to +1 and multiplies to -20? Yeah? Yeah, +5 and -4. And it can't be -5 and +4 because we're adding here to a +1. Yeah? How about this next one here? Yeah, Sean? Yeah. -5 and -4 for sure. And this last one, what do we got? -4 and +8. Yeah. Now, that is lovely. In fact, did you enjoy that? Was that kind of like, for me, that's kind of fun. I don't know why. I don't know if that's the nerd in me or whether it's just I really like multiplication tables. But if you found that okay, you might find today's lesson pretty okay. I can almost like stop teaching now, and I think you'd be pretty great at what we're going to do today. Because what we're doing today is factoring, okay? And yesterday we did common factoring, which was super awesome and important. But today what we're going to do is, if you look at the bottom here, we know how to expand this thing at the bottom using FOIL. But what we're going to learn today is to go the other way. So essentially, what we're learning is how to undo FOIL, like how to undo this trinomial back into two binomials multiplying by one another. So before we do that, let's really recall what FOIL was. And I know you're great at it, and we just had a test on it. So when we have these two binomials multiplying by one another, I like to see it as double distributive property, right? We distribute to each term in the second bracket from the first term, and we distribute to each term in the bracket from the second term. So we'll get something like x squared plus 3x plus 2x plus 6. And we always end up collecting the like terms, and the like terms are usually always the middle terms here. Yeah, the x terms. Great. And I'm sure you really took off with this stuff. Here we go. X times x, x times 5, 4 times x, and 4 times 5. So we'll get something like x squared plus 5x plus 4x plus 20, right? When they're all positive, right? When you have positives in each bracket, it's kind of nice. You can kind of fly through it. And we collect our like terms again, just like that. And the last one, I know you're great at it. We got x squared plus 1x plus 7x plus 7. And we collect our like terms again. Okay, now, the question here, and it's a very important question, I do want you to take some time to think about it and talk about it with the people in here. It says, what do you notice about the b and the c values in the trinomial? And when they say b and c values, what they really mean is like the b and the c values. So essentially the x term in the middle and then the constant term at the end. What do you notice about those two values in the trinomials? And then compare them to the numbers that are in the brackets. Okay? So maybe take 30 seconds, chat about it with the people around you. What do you notice about the B and the C, and then the numbers in the brackets? Go ahead.
You got 5, 6, 2, and 3. Okay. How about 9 and 20? 4 and 1? Isn't that weird? What's going on? What's going on? The B. And then what about the C value? Yes.
Folks, do we have an answer? Did you chat about it? Is that enough time? What do you notice? Yeah. Okay. So Shaq says the B value is essentially the sum of the two numbers in the bracket, and then the C value is essentially the product of the two numbers in the bracket. And that's exactly true. Have a look. We have the numbers 2 and 3, right? 2 plus 3, if we add them, we get 5. If we multiply them, we get 6. And that's going to be true for all three of these. 4 plus 5 is 9. 4 times 5 is 20. Okay? 7 plus 1 is 8. 7 times 1 is 7. Now, that is not a coincidence. In fact, the reason why this works, we will get into it, but I want to take note that each one of these trinomials that we work with today has an a value that is equal to 1. So it's always going to be 1x squared, or just x squared. Yeah? Now, when it's not 1, we got some exciting stuff that happens. But for right now, this is our first step into factoring. The a value is just going to be 1. So let's write that down. It says the numbers always add to give you b, and the same numbers will multiply to give you c. Oh, it's April Fools. Happy April Fools. So very similar to common factoring, when we factor anything, we usually write it as a product, right? We write it as a multiplication statement. So down here, we know how to go the expanding route. We love expanding. In fact, we just did it here, and I think we're very confident in that. And now if you look at the factoring route, if we're going from this side here, right? We're going this way. All you have to do is look for two numbers that multiply to 6 and the same numbers that add to 5. Because look, it's just 2 and 3. And for whatever reason here that we will get into, we put x plus that number, and then if it's a positive 2, we put x plus 2. If it was a negative 2, we would put x minus 2. But it's just, they go in brackets like that. And that's a little weird right now, but I'm going to explain why that happens. Okay, now just to prove to you that it's always going to be adding to the middle one, yeah, and then multiplying to the last number here, right? Like this is ax, we're going to get to ax squared plus bx plus c. Now let's just FOIL something like this, where the x term has got a coefficient of 1, and then m and n are just any numbers here. Now this is just theory based, you wouldn't be tested or anything like this, so I just want to show you what happens. X times x is always going to be x squared, right? And then x times n, like let's just say that was like 2. Then our product here would be like 2x, but in this case we're going to say nx. M times x is mx. And then m times n is mn. Yeah? And then notice, like this always happens, those middle two terms were like terms. So what we can do is add them together, or I guess what we could say is common, in this case we just kind of common factor. I guess what we have is n plus mx plus mn. So this kind of solidifies the fact that we will for sure always be adding to get the b value, because it's showing you, right? Like we add these two numbers to get the b value. And then we're always multiplying, right? M times n here, multiplying to get the c value. That's just always what happens. And I wrote here, we can see that in our answer. The middle number is the result of adding, yes? Great. And then the last number is the result of multiplying. Okay. Now, let's go ahead and factor our very first trinomial. This is something that, kind of like a great tool to use. You probably won't use it all the time because you might just be so good at multiplication tables that you won't need to use this tool. But for this lesson, we're going to use it. So we know that we're trying to find two numbers that multiply to 18, right? Multiply to 18. And the same two numbers will add to 11. So what I'm going to do in this column, you probably already know what that is. Probably already know the answer. But what I'm going to do in this column is write down all of the factors of 18. So for example, 1 times 18 is 18. In fact, -1 times -18 equals positive 18. Yeah? Now how about 2? 2 times 9 is 18, and also -2 times -9 is positive 18. Is there a 3? Yeah, 3 and 6. 3 and 6, and then that would be -3 and -6. And then we'll end up at 9 and 2 again. Yeah, so like we kind of already have that because with multiplication, the communicative property doesn't matter which way you multiply, right? It could be 9 times 2 or 2 times 9 is the same idea. Now what we're going to do is add all these, and we're going to figure out which one adds to 11. So this one we get 1 plus 18 is 19, so we're not looking at that, right? And this one, of course, would be -19, so we don't look at that. And then we see 2 and 9 gives us positive 11, and we're really, really happy about that. In fact, I put a check mark beside it, and I circle it, because that integer pair, 2 and 9, are the numbers that will make this thing work. Now, essentially, what you're going to do is this. You're going to say, okay, this factors to x positive 2 times x positive 9. Now, what we call that is very simple factoring. That's what we call it. That answer would be allowed. I would accept it, and any teacher would accept it. Now, you're probably wondering, well, how does that even happen? Why are we allowed to just do that? Because when I first learned factoring, I didn't like that. I was like, okay, sure, you tell me to do it, and that's fine. I can take your word for it because you're the teacher, but what is actually going on? Well, this is what we call, I guess, short. This is the short factoring. How we just give them an answer, because that's really all we're after. Now I can show you the long factoring here. I'm going to show you truly what's going on. So we have here x squared plus 11x plus 18. Now those two magical numbers, the 2 and the 9, okay, we know that they have to add together to get that middle term, correct? So what we do with this middle term is we kind of break up the 11x. We break it up. We break it up into a 2x, a positive 2x that is, and a positive 9x. Because that, in fact, adds up to the 11. And we know that those are the two numbers that'll add to b. Okay. And what hasn't changed is the x squared and also the plus 18 there. Now, we have 4 terms, folks. Do you remember when we took up homework first thing today? We had 4 terms. When we have 4 terms, we often just group factor. I'm going to group these together. And then I'm going to group these together. Can we common factor anything out of the blue group? Yeah, we common factor out an x. X bracket x plus 2. And can we common factor anything out of the green group? Absolutely. A 9 bracket x plus 2. Oh. We can go one more step in factoring. Sorry, can you see that from back there? We can go one more step in factoring and common factor the x plus 2. So we can say, okay, x plus 2, and then we have x plus 9. And after yesterday's homework, that should be very clear. Does that feel okay so far? So this is what we call long factoring. Like, look at the result we ended up here, doing all of this work, when we we knew that. We knew we were going to end up there. We truly knew it. So this long factoring will come in handy, I promise. This is not nonsense. It's going to come in handy, but for today, we're not too worried about this long factoring. We can save that for when we need it. And for this, when the a value here is set to 1, we have 1x squared, we don't need to long factor. We can just use our short, we call simple factoring method. Okay? Any questions about this? Okay, because if this is good, then wow, oh, wow, this is going to be a great unit for you. Okay, let's try this again. X squared plus 8x plus 12. So essentially, we are looking for two numbers that multiply to the last one, right? Multiply here, and we're adding to the 8. So I'm not even going to think. I'm just going to go 1 and 12. And I know it's not going to be any negative numbers because our sum is positive 8. So 1 and 12, 2 and 6, 3 and 4, and I guess the next thing would be 6 and 2 and this and that. So which one of these add to 8? It's not this one. This adds to 13. This is the one that adds to 8. This is the one we want, the 2 and the 6. So we could do long factoring, but instead of that, we're just going to say, okay, equals x plus 2 and then x plus 6. Isn't that great? Isn't that great? It saves so much time. It does. Now, let's check. It says, when done, check by using FOIL. Okay, no problem. We're going to take our answer, our x plus 2 and the x plus 6. And what we're hoping happens is that after we FOIL this, or these factors, we're going to multiply the two binomials, and we're hoping that our answer is the exact same as the original question, because that'll solidify that this binomial, these multiplying binomials here, is equivalent to the trinomial. So here we go. We got x squared plus 6x plus 2x plus 12. And then we collect our like terms in the center, as always, plus 8x plus 12. And is that the same as the original? X squared, got it. X squared plus 8x plus 12. So we can give ourselves a big check mark and say, yeah, we're absolutely right. We know that this factor here is equivalent to the trinomial up there. It's kind of nice. Questions about that? Feeling good about it? Okay, great. Okay, maybe try these ones. Try them on your own. What I like to do with these types of things, when there's no space for anything, you could draw this table here, yeah? But also what I like to do is to do little sentences, like math sentences. And I'll show you what I mean by that. Something times something equals 9. Something plus something equals -10. And I think, I'm like, okay. And I just trial and error this. I'm like, okay, 4 and 5. Okay, no, it can't be 4 and 5. -9, -1. Yeah, -9, -1. -9 times -1 is +9. Great. -9 plus -1 is -10. So we've cracked the code. And here's our answer. X minus 9, X minus 1. You see that? They want us to check. No problem. Here comes the check. We say we got X minus 9 and X minus 1. All right, here we go. We're going to FOIL. X squared minus 1x minus 9x, careful here, plus 9. X squared minus 10x plus 9. Is that what we got it at the original? It sure is. We got it. We're great. Folks, questions at all? Okay. How about here? Our little sentence. Something times something equals -15. Something plus something equals -14. Oh, it's always something in one, isn't it? This one's going to be -15 and +1. -15, +1. That works. Good. -15 plus +1 works. Lovely. We go here x minus 15 because it's a -15. And we're going to write x plus 1 because it's a +1. So essentially, whatever your magic number is, the sign will come with it in the bracket. And of course, they would like us to check here. No problem at all. We kind of laugh at this step. We're like, oh, okay, you want me to FOIL one of these things? No problem. Let me add it. Here we go. X squared plus 1x minus 15x minus 15. Oops, not 115, you silly. And x squared minus 14x minus 15. Is that the same as the original? It sure is, and we're great. So very similar to Unit 1, the linear systems, where you're able to check your algebra. You can check whether you got the right answer or not. That's one of the beautiful things about factoring is that, if I give you an assignment or a test or a quiz or anything like that, you can just check your answer and be like, okay, I got this one right. Or maybe I didn't, and I got to go and check it out. Okay. Try these 4 on your own. Try them. Give them a shot. Not sure how you want to do it. Some of you could just do it all in your head. Some of you want to write down the math sentences. Others maybe want that sum and product chart, right? The table, rather. Any method is going to work.
Don't forget it. I think that because when you multiply, right? 2 times 3 or 3 times 2, yeah, the communicative property allows us to
Okay, for me, I need to write this down. I need to see it like this. Something times something equals 18. Something plus something equals 9. I don't know. I love to see it. What did you say? 6 and 3? 6 times 3? Positive 6, positive 3 is 18. Positive 6, positive 3 is 9. Yeah. So we throw it equal sign and then go x plus 6, x plus 3. A great question came out and said, Mr. Yakmission, I have x plus 3, then x plus 6. Does the order matter? It doesn't matter. Because when you can multiply in whatever order. So as long as you have both of those factors, you're in great shape. Okay. Something times something equals positive 20. And then something plus something equals negative 9. We got a positive product and then a negative sum. So I think both the numbers are going to be negative. I think. Negative. What you could do is this. Multiplying to 20, adding to negative 9. Negative 1, negative 20. Nope. Negative 2, negative 10. Nope. 3, no. 4. Yeah, 4. Negative 4 and negative 4. Oh, there it is. Lovely. Negative 4, negative 5. Negative 4 times negative 5, positive 20. Negative 4 plus negative 5 is negative 9. Okay, we're in great shape. X minus 4, x minus 5. Okay. Multiplies to negative 28 and adds to negative 3. Someone have an answer for C here? Yeah, what do you got? Minus 7 plus 4. I agree with that. And then minus 7 plus 4. I agree with that. Okay. X minus 7, x plus 4. Okay, great. And then the last one here, two numbers that multiply to negative 15 and the same numbers add to positive 2. That's the thing, like, we always got to consider the sign to the left of the term. Like, in this example, it was minus 28, so that means we're multiplying to a negative 28, things like that. 5 and 3 comes to my head, 5 and 3. 5 and 3? No. Yes? Positive 5, negative 3. Positive 5, negative 3. Now, I feel like the trick is always start with the multiplying one. For whatever reason, that makes me feel a little bit at ease when I do that. X plus 5, x minus 3. Okay. Folks, there's some patterns down here. I am not a huge fan of these patterns, but if you would like to read them on your own, that's great. I'm not too focused on patterns. I like to crack the code. That's the way my brain looks at these things. But there are patterns that do exist, not necessary to memorize or know or anything like that. They're just there for I guess, some funsies. Folks, any questions about this before we move on to the very last one here? Okay. Now, I told you this whole time, that a value in ax squared plus bx plus c, the a value was always 1. So essentially it was x squared plus bx plus c. These are the types of trinomials we've been dealing with. That a value is just 1 every single time. That's what we call simple factor, simple trinomials. Check these out. None of them have an a value that is equal to 1. So the first question in factoring that you have to ask yourself every single time is there a common factor? So if we have a look at this first example, do you see a common factor here? The greatest common factor? What is the greatest common factor here? 3. So I might even do the same thing that we did the other day. The GCF is 3. So I'm dividing everything by 3, and we're going to keep the 3 out front. Do you see that? If the 3 was no longer here, that's a totally different trinomial. We have to make sure that that 3 stays out front. Plus, what do we got? 12x plus 20. Lovely. Okay, so we got that far. Great. That 3 must stay out front. Yeah. So, can we go one step further? Look inside the brackets. Something times something is going to equal 20. Yeah? Something plus something is going to equal 12. What are those two magical numbers that'll make this work? 10 and 2. 10 and 2. Lovely. So when we write down this final answer, we must ensure that the greatest common factor remains out front here, and then we can change this trinomial into x plus 10 times x plus 2. That's what I meant by we're going to piggyback a little bit off of yesterday's stuff. You see it? Greatest common factor, and then simple factoring this trinomial in brackets. Any questions about that? That sit well? Sit okay? All right, let's try another one here. The very last one, we have a negative 2. And like I mentioned on yesterday, if you have a negative leading term here, we should common factor out the negative. So our greatest common factor here is going to be negative 2. So we're going to divide this by negative 2, this by negative 2, and this by negative 2. And I'm sure you know that when you divide by a negative, you got to be extra cautious here because things will start changing signs. So for example, we're going to get a positive x squared, a minus 10x, and a plus 4. Now, our next move, by nature, should be, can we factor this trinomial? Are there two numbers, think about this, are there two numbers that multiply to 4 and then add to negative 10? Do those numbers exist? No, they don't exist. So we can't actually factor any further than this. Cannot factor further. And that can happen because something times something equals 4, something plus something equals negative 10. It just doesn't work. It doesn't work. There's nothing that'll do that. And in fact, we would call this trinomial in the brackets there, we would call this, it's not factorable. Now, does that come up a whole lot? I mean, I would never give you one of those on a quiz or a test. And if I did, I might have made an error in creating that question. So if that does come up on something that I'm assigning to you, please let me know because I might have messed something up. But in the textbook, I think they might throw 1 at you or maybe 2 at you. Okay? So if you ever run into a scenario where you're unable to calculate the numbers, I would say 1 out of 100 chance you might run into this. 1 out of 100. Okay? All good? Okay. Folks, the homework's down here. It's quite a bit. It's great homework to be doing, I promise. It's well worth your time. I'm going to be up here if you need anything. Mm-hmm.